Hello guys, welcome to the chemistry lesson. In today's lesson, we'll be looking at the alloys. Alright, so today's lesson we'll be looking at the alloys. So without wasting much of your time guys, you should know that the alloys or an alloy is a homogeneous mixture of two or more metals or metals and nanometals formed by mixing molten metals thoroughly. So guys, an alloy is a homogeneous mixture of two or more metals or metals and nanometals formed by mixing molten metals thoroughly. Alright, so when two or more metals are mixed thoroughly, then it forms actually what we call an alloy. And an alloy is a homogeneous mixture. All right, it's a mixture, it's not a compound. And by homogeneous here, we mean that metals can be mixed uniformly in a way that you won't be able to identify the distinct components that make up actually the alloy. When the two metals are combined to make an alloy, you won't be able to identify the metal, the individual metal in that particular alloy. All right, so that's what we mean when we say an alloy is a homogeneous mixture of two or more metals or metals and nanometals formed by mixing molten metals thoroughly. And by molten here we mean that these metals, before they are mixed to make an alloy, they need to be in a form of a liquid, like they have to be melted, and that form of a liquid in which metals exist is what we call molten. All right, so for example, let's say we have a zinc metal here, and then we have, let's say this one is the copper metal. All right, so when zinc metal and copper metal are added, they form an alloy actually like this one, and such an alloy is known as the brass. So this one will be brass alloy, which is an alloy made of zinc and the copper. All right, so also what you should know is that elements in large proportion are called base elements, while those in small proportion are called alloying elements. So whenever alloys are being made, any element that is in large proportion or amount will be called the base element. Then that other element which will be in small proportion or small amount, it will be called the alloying element. All right, so what you should also know is that it is generally found that the alloying metals produces a metallic substance that has more useful properties than the original pure metals it was made from, or it is made from. All right, so this is what you should do. Understand that the alloying metals produces metallic substances that have useful properties. So those metallic substances that are formed as a result of alloying have got more useful properties than the actual element from which or metal they are made, and that's the reason why alloying is done. All right, so let's push this one up here. So also now let's look at the examples. So for example, brass brass alloy is harder and more corrosion resistant than either of the metals it is made from. Yeah, so we are just emphasizing on this point where we said that it is generally found that alloying metals produces a metallic substance that has more useful properties than the original pure metals it is made from. And we are giving an example here. We are saying, for example, brass alloy is harder and more corrosion resistant than either of the metals it is made from. You know, brass is made from copper and zinc, so it is actually harder, and then it is also corrosion resistant than actually copper or zinc. All right, now let's look at examples of alloys. All right, so we already know this one. We have brass as an alloy, So brass as an alloy. So this brass is made actually of this brass is actually made of brass is actually an alloy of copper and the zinc. All right. So also another alloy is actually bronze. So bronze is an alloy of copper and the tin. Then another alloy is actually steel. So steel is actually an alloy of iron and the carbon. All right. So these are examples of alloys that must be at your back of your mind, at your fingertip whenever you remember alloys. These are very common alloys at your fingertip that you shouldn't be able to forget. Now let's look at now diagrammatic representation of alloys. So in terms of a drawing, how are alloys represented? An alloy, the atoms of the second metal must enter the lattice of first metal. Yeah, so here what we mean is, remember, metals are arranged in a regular pattern, but whenever you are alloying them, then that other second metal must enter in between the atoms of the second metal. So the atoms of the second metal must enter in between the atoms of the first metal. So you need to melt the metals first, then mix them. So in making alloys, metals that make up the alloy first, they have to be melted. All right, so you will understand properly when I give these diagrams here. So that these diagrams are actually that are giving examples of diagrammatic representation of these alloys. For instance, we talked of brass alloy here, which is an alloy of copper and zinc. So let's say copper atoms are represented by this shape here, and zinc atoms are represented by this shape here. So in a brass structure, when they combine it to form a brass alloy here, this is how the structure is going to look like. So if this is the first atom, then of which is copper, then the second will be zinc, the third copper, again, if you have steel alloy, which is an alloy of iron and the carbon, if let's say these iron atoms are represented by this shape, and then carbon atoms by this shape, then also they are going to alternate in steel structure like this here. All right, so this is how you write actually or draw a diagrammatic representation of alloys. Very, very important. Now let's look at now advantages of alloying metals. Right now we are looking at the advantages of alloying metals. In other words, we are saying we are talking about the importance or the usefulness of actually making alloys. What are their advantages over the original metals they are made from? The reason why we make alloys. So they've got actual advantages, and then we are looking at this advantage. So advantage number one is that alloys are harder and stronger than pure metals. So that's what you should know, guys, that alloys are harder and stronger than pure metals. So here we are saying pure metals are weak and soft. This is because atoms of the same metal have the same size and are regularly arranged in layers which can slide over each other easily when force is applied. Yeah. So the reason why alloys are harder and stronger than pure metals is this explanation here, where we are saying this is because atoms of the same metal have the same size. Okay, so atoms of the same metal, they will have the same size, and are regularly arranged in layers, and these layers which can slide over each other easily when a force is applied. So let's see this information using a diagram. So let's look at the pure metal structure. So a pure metal structure, we are saying it will have the same atoms and of the same size and regularly arranged. So in layers, so we have regular arrangement of layers. So what we are saying is that when a force is applied, let's say on this layer here, so if a force is applied, this layer is going to slide like that. And this is why pure metals are actually weak and soft than actually alloy. All right, so we are saying pure metals are thus soft and malleable. All right, then now we have talked about pure metals here. Now let's say when a pure metal is alloyed, a different element is added to the pure metal. Yeah, so when an pure metal is alloyed, a different metal is added to the pure metal. So this disrupts the regular arrangement of atoms in the pure metal by addition of other atoms of a different size. Yeah, so let's say this is now an alloy structure. So in this alloy structure, you'd find that if a different metal is added with a different size of atom, like in this case we have this is a pure metal that we looked at. Now it has been alloyed by adding another metal whose atoms are bigger than this. So you find that the layer now will be disrupted. So like here we have this layer here in this structure, another layer here, but here we are not going to have a layer here, and here will not have a layer because this atom is bigger, so it has actually blocked this layer here. Only down here where we have a layer. So let's say now a force is applied here. So if a force is applied here, so these will not be able to slide the way they did in a pure metal, because these atoms now, they will be like this 1, 2. They'll be blocked on this one here, so they will not be able to pass because this is locked into this big atom is locked into these others, and also because of that it cannot be pushed. So if it were to be pushed, unless it carries also even those, which is harder than just sliding them like that without this one. So we are saying that therefore it is difficult for the atoms in an alloy to slide over each other. Yeah, so it is difficult for atoms in an alloy to slide over each other, and then we are saying this makes alloys harder, stronger, and less malleable than pure metals. So this is an explanation now why alloys are harder, stronger than actually the pure metals. So this explanation has been made for you to understand. So another advantage of alloys is that alloys have a higher resistance to corrosion and than pure metals. Yeah, so alloys usually are very strong to resistance. All right, like stainless steel, there are certain knives that are made of stainless steel. Even if they touch water, they don't undergo rusting or corrosion because actually they are made of alloy, which is stainless steel. So alloys have a higher resistance to corrosion than pure metals. E.g., we are saying coins made of copper, nickel alloy have higher resistance to corrosion than when they are made from the pure metal. Yeah, so coins, we know coins, that is money, metal money. So that money actually is made of copper, nickel alloy. And because copper nickel alloy is resistant to corrosion, then that makes the money very, very durable. Even when it is exchanged in hands, it does not corrode. all right, because it has high resistance to corrosion. And like if it is made from nickel or copper, then it can undergo corrosion. Then another advantage of alloying is that alloying is used to lower the melting points of metals. Yeah, so alloying is also important in making the melting point of metals to be lower. E.g., we are talking of soda. So soda is an alloy of tin and lead and has a lower melting point than its constituent metals, thus can be used to join metals. So you know this solder is actually called soldering wire. So soldering wire has the low melting point, and because of that it is able to melt as it is used to join other metals and the wires. All right, so that's what alloying does. So it lowers the melting points of metals. Then another advantage is that alloys have improved metal appearance, so they actually improve the appearance of metals. For instance, in the previous lesson where we looked at the uses of metals, we talked of brass where we looked at its appearance, and the bronze, those were good appearance that we saw. All right, so alloys have improved the metal appearance. All right, so we are done with the advantages of alloys. Now let's look at the uses of alloys. All right, so with me here I have a table. So in this table we have alloys, then composition of the alloy, uses of the alloy, then the useful property upon which the use depends. So for instance, here we have milled steel as an alloy, and its composition is that it is made up of iron and carbon, and its uses is that in car bodies, large structures, and machinery. And then the property that enables it to be used here is that it is hard and strong, and then here easily worked on. All right, then another alloy is stainless steel, which is made of iron, chromium, and nickel. And its function in stainless steel is in cutlery, in short, for making knives, and also in a surgical instrument, for making those surgical instruments which we know. All right, so when we talk of cutlery here, knives, spoons, forks, and the other things. All right, so surgical instrument. Then why it is used here is that it is corrosion resistant, so it does not undergo corrosion or rather rusting. All right, so another alloy is brass, and brass is made of 65% copper and then 35% zinc. So meaning base element actually here is copper, then alloying element is actually zinc. So its use, this bronze, is that in making screws, ornaments, musical instruments, and also door knobs, all right, or handles. And then the reason why it is used like this is because of this property. It is harder than copper. So brass is harder than copper and does not corrode. All right, another alloy is actually bronze, and then bronze is actually made of 90% copper and also 10% tin. And its use is that in making ornament, castings, and the machine parts. And then the reason why it has these uh, uses here is because it has this property which is good appearance. All right, then another one is a duralumin. All right, so duralumin is 95% aluminium, 4% copper, 1% magnesium, and then manganese and iron. And it's used in aircraft and bicycle frames. And the reason why it is used in aircraft and bicycle frames is that it has this useful property. It is strong and also lightweight. All right, so let's move to the next page. Here we have soda. Soda is made of 70% lead and 30% tin. And then its use is in welding metals or connecting electrical wiring. All right, and why it is used in welding metals or connecting electrical wiring is that it has low melting point. Then another alloy is tungsten steel, which is made of 95% iron, 5% tungsten. and then its use is in edges of high speed cutting tools. So it is used in edges of high speed cutting tools like the axes. Then we can talk of grinding wheels. I think those for a cutting disc. I mean, we have cutting discs. All right, so those must be coated with the tungsten steel. All right, so for cutting other metals, because the reason why it is used in edges of high speed cutting tools is because it is tough, hard, even at high melting, at high temperature. Excuse me. All right, so now let's look at now the harmful effects of metals. So metals, even if they have these advantages and uses, we have metals like lead. All right, so we have lead, which is actually lead. We have lead poisoning, actually, which is actually which causes brain damage. So this is actually lead poisoning from the actual metal lead. Then we have also sodium ions, which are there in rising, which cause rising high blood pressure. All right, so then we have also this one, alzheimer, which is caused by aluminium. Alzheimer is a condition where a person has got a memory loss. All right, so guys, we have come to the end of this chemistry lesson. I hope you have enjoyed it and you have learned something about the alloys. So if you have enjoyed it and you have learned something about alloys in this video, please give it a like and also let me know in the comment section. As for now, guys, bye and see you in the next lesson.